All right, let's get straight into it. Today, we're going to decode exactly how you can lock in every single mark on a GCSE Physics question. And how are we going to do that? By looking at the only thing that really matters, the official mark scheme. Let's dive in.
So this is what we're working from. This is the official AQA mark scheme from the June 2018 higher tier paper. This isn't just some helpful guide, This is the exact document the examiners use to decide who gets the marks and who doesn't. Understanding this thing is the key to cracking the exam.
I mean, we've all been there, right? You write down an answer, you think it's perfect, but you don't get full marks, and you're left wondering, why? Well, the secret is all in the super specific wording that the examiners are trained to look for. And today, we're going to pull back the curtain on question 07.
Okay, first up, part 7.1. This is a 1-mark question. That means you have to be super precise. There's absolutely no room to waffle here. You either hit the point or you don't.
Okay, now look at how this table is laid out. The first column gives you the main answers they'll accept. So either too few turns on the secondary or PD across the primary was reduced. But the real gold, the bit you need to pay attention to, is that extra information column. The word allow tells you they'll also accept number of turns on the primary was increased. And see that word ignore? That's crucial. If you write down human error, they won't mark you down for it, but you're not getting any marks either.
So just to make it crystal clear, for that single mark on 071, you've got these 3 possible winning answers. You only need to write down one of them. The mark scheme is literally giving you options to choose from.
All right, let's move on to 07.2 and see what's next. It's another 1-mark question, and no surprises here. The mark scheme is looking for very specific phrasing to give you the point. It's all about reading the data they give you in the question. So the main point here is that the potential difference, or PD, across that secondary coil goes above 2 volts. That's your primary answer. But again, you've got to check that extra information column. It says they will allow PD across secondary is higher than PD across primary after 20 turns. See? 2 different ways to phrase it, both get you the exact same mark.
So there you have it, the 2 correct answers for 07.2. You can either say the secondary PD goes over 2 volts, or you can compare the primary and secondary PD after 20 turns. Either one works, and either one gets you the point.
All right, time for the big one. Question 07.4. It's a 5-mark calculation. This is where showing you're working clearly and methodically is everything. 5 marks means there are several steps, and the mark scheme lays out exactly what an examiner needs to see for each of those steps. This is the million-dollar question, isn't it? Well, it's not just about magically getting the right number at the end. It's about showing how you got there. And the mark scheme gives you the literal roadmap to get all 5 of those precious marks.
And what's really cool about this question is that there's not just one path to the right answer. The official mark scheme actually lays out 2 totally different but completely valid methods. We're going to walk through the first one right now, step by step.
Okay, so check this out. Step 1 is just putting the right numbers into the transformer equation. Boom, that's your first mark. Step 2, you rearrange it to find the primary voltage, VP. Step 3 is getting the right answer for VP, which is 280 volts. You're already at 3 marks. Then, step 4, you use the power equation and plug in the 280 you just found. And finally, step 5 is the last calculation to get the primary current, IP, which is 1.2 amps. Every single step gets you a mark.
But what if you didn't think to start with the voltage ratio? No problem at all. The mark scheme shows there's another way. So let's check out method 2. It starts from a completely different angle but ends up at the exact same answer.
So this method kicks off with the power equation, but this time to find the secondary current, IS. That calculation gets you to 192 amps. Then you use the transformer equation for current and turns, popping in that 192 you just worked out. One last calculation, and look at that, you land on the very same answer, 1.2 amps. A totally different journey, but it gets you to the same place for the full 5 marks.
Now, here's a really interesting little detail from the mark scheme. It actually says that if you just write down the answer, 1.2 amps, with no working out at all, you get all 5 marks. It's sometimes called a bald correct answer. But, and this is a huge but, it is always, always safer to show you're working. If you make one tiny mistake on your calculator and get the final number wrong, you get 0. If you show your steps, you can still pick up most of the marks along the way.
And this, right here, is exactly why showing your work is so important. It's a concept called error carried forward.
Let's say in method 1, you accidentally calculated VP as 270 volts instead of 280. If you then used that wrong number correctly in the next step, you would still get the mark for that step. You only get penalized for the first mistake. It's an absolute lifeline.
So, the next time you're looking at a mark scheme, don't just glance at the answers. Really study the language. Look for those keywords like allow and ignore, and look for notes about error carried forward. That's not just extra information. That is the hidden rule book to getting the best possible score. You've got to read it carefully